Okay, we're going to do the second part of the fundamental functions, and here we go. If you get something that looks like a hyperbola here that has an x in the bottom, it's so easy because whatever this number is, y equals minus 2. If you go to the y line where minus 2 is and put a line, you get a mark because you just did the asymptote for sketching the graph. The opposite of this number is called the vertical asymptote. You just go to 1 and make a vertical line right there. X equals 1. Right at x equals 1. And let's put it over there. Right at x equals 1. And now you've got the two asymptotes, and it's much easier to sketch the graph. If you let x equal 0, if you put a 0 in there, you'd have, and you could put it in your calculator, 2 over 0 minus 1 minus 2, your calculator would say minus 4. You'd get another mark. If you knew there were two branches, that's a y-intercept. Now to get the x-intercept, we need to make y equal 0. We need to make y equal 0. So you do that. You make y equal 0, and you're thinking, what would make this 0? Now, if you know how to do the algebra to get it, multiply everything by x minus 1 and then solve the equation. But sometimes it's easy just to see the answer. The only way I can get 0 is if this was equal to 2. 2 minus 2 is 0. Well, what number would I put in here so that this would be 2? Well, 2 divided by 1 would be equal to 2. Well, then I have to somehow figure out, how am I going to make this 1? Well, 2 minus 1 is 1. And then it would make it all work. It would make it 0. So you can just look for a number that will make it true. So 2 is the x-intercept. Now, they do come up with questions all the time where they ask about domain and range, and you have to know what the word means. Domain means all the possible x values. Well, you can put just about anything in for x here, but there's one thing you can't put in. 1 minus 1 would be 0, and you're not allowed to divide by 0. So the domain is all values, real numbers, but x can't equal 1. That's the key thing. That's your domain. Now, if they said, what's the range? Well, because this can never equal 0, it can never be 0 because it's undefined, then y can never be minus 2. You see, y can never be minus 2, and x can never be 1. That's the range. Y is an element of the real numbers, but y cannot equal 2. X is an element of the real numbers, but x can't equal 1. Let's look at the last thing. It's an inverse function. It's an inverse function, and let's say they gave you this exponential function. It's a little bit like that, but it's sort of a little bit different. But say you were given this function, y equals 2 to the x. Well, if I let x equal 0, I could find that 2. If I let x equal 2, 2 to the second power would make it 4. Well, I'd have that point, that point. Exponential looks like this. I'm adding, the asymptote is 0, so it's y equals 0, y equals 0. Anyways, that's the exponential function. But if they said, find the inverse, well, instead of f of x, you write y equals 2 to the x. And if they say determine the inverse, all you do is switch x and y. Switch x and y. And now the next part is a little bit trickier because you have to use the log idea. You know that the log of something, you have to look up here and go, what's the base? Well, the base of this exponential number is 2. So it's a log to base 2. And what is a log? It's an exponent. So that's why the y goes there. The log to base 2 of this number is equal to y. So the exponent is the log. And that's your answer. Y equals the log to base 2 of x. But no matter what function you have, if you want to find an inverse, write y equals, then switch x and y, and then solve for y. But with exponential ones, we have to use this log thing. Just remember the base goes there, x is there, and it says y equals, so it's got to be y equals. Now here's a little bit of a tricky question. Oh, and maybe just before we get there, all inverse functions are reflections in this line. Like this is the mirror, this is the inverse function if you're given that. And if that's 2 and 4, that'd be 4 and 2. And if that's 0 and 2, you just switch x and y to get the inverse 2 and 0. If this is going close to the x-axis this way, this one must be to the y. So that's how inverse functions work. If you got this question, for which values of x would the inverse function be greater than 4? Well, there it is 2. How big would x have to be it bigger than 4? Well, all you do is you go, well, let's figure out what x is when y is 4. Well, it's the log to base 2 of x when y is 4. We've got to find that number. Well, there's the base, 2. The log is a power, 2 to the 4th. Well, that must be what the number is, 16. So x has to be bigger than 16. Way out here at 16, y will be 4. When will it be bigger? When x is bigger than 16. It'll make the y value bigger than 4. Okay, so maybe if you give those inverse functions, if you just remember, switch x and y, and then make y the subject. And if it's log, and if it's exponential, you got to use logs. But you're still solving for y there to get the inverse function. Well, I hope that helps when you try to do an inverse thing again. Okay. Alrighty.